Okay, welcome back to the Simon Center. Again, it's a real pleasure to have one more event sponsored by the De La Pietra families. We have Pam Hirsch De La Pietra who is joining us. The other three are busy in other activities. But we are grateful for the fact that they continue to have unwavering support to Stony Brook, and in particular the Simon Center in all its activities. And in fact, they are providing support for a series of lectures that have become very famous, and we have always extremely good lecturers coming, like in this case of Dava Sobel. So I'd like to thank Pam once again. Now, normally when we try to prepare this lecture, a few of us start doing some brainstorming and thinking about possible people to invite. And I always thought about Dava Sobel because I've read all her books, and I've always been fascinated by the way she writes and the way she tells the stories. And then I wrote, believing that she would never reply to me while we're talking to Michael Carlyle. But in fact, in a few days, the deal was done. And now the miracle happened, and she's with us. In fact, she went to graduate, just a few words. She graduated in the Bronx High School of Science, where some of our most prestigious colleagues went to high school. For example, Steve Weinberg, Shelley Glashow. So it's a school that really has an incredible pedigree. Then she went to Binghamton University, and then she's also been doing some teaching of science writing in Chicago. She's been doing lectures all over the place. She writes in many different journals, magazines, and so on. I'm not going to bore you about it. And her books are just mesmerizing. She's someone who is able to entertain, but inform. She doesn't just draw a canvas, but what she does is she creates a stage where you can see that the actors and the protagonists of the different stories come live. And it's an absolute wonder to read her books. So without further ado, please, Dava.
Thank you. Thank you. Thank you very much. Can you hear me?
Yes.
Okay, great. Welcome, everyone. I'm really excited to be invited to give this lecture. Very grateful to the De La Pietra family and to be in this beautiful space with all of you and tell you a story, one of the stories that really interested me about women in science. I have not always been interested in stories about women. I'll get the hang of this. There we are. I'm late coming to the difficulties of women in science, but I'm glad to be here now. And this story I find particularly engaging. I called my book The Glass Universe because it's about a collection of glass photographic plates that really contain the whole sky. But anytime you talk about glass and women in science, there's also the glass ceiling. And I was intentionally playing on that association, the glass universe and the glass ceiling, but I live to regret it because many people, including my publisher, accidentally refer to the book as The Glass Ceiling, which is not the title of the book. Oh dear, we have gone back to, we're having technical difficulties, Josh.
The microphone.
No. I pushed the wrong button. That's the technical difficulty. This used to be my screensaver. I'm just going to fill the time till we iron this out. Here we are. Okay. And sometimes that just comes up instead of the presentation. Okay, thank you. Okay, so this is what some of the plates look like, just to give you a sense of size. Most of them are about 8 inches by 10. I usually have a replica plate that I bring with me to show people, but I couldn't bring it today, and I will tell you why later. So the story takes place at the Harvard College Observatory in Cambridge, Massachusetts. This building is obviously an observatory. You can see the big telescope domes, but it also has this part to it. Well, I have to point it out on both sides, maybe. So that is the director's residence. And because the director lived on site, it was very easy for him to indoctrinate his family and just move them into the observatory to do whatever needed to be done. So it was common for the director's wife, sister, daughter to be taught the necessary tasks and to be working in the observatory. And this person took over the directorship in 1877. And he was only 30 years old. And there was some question as to whether he was really fit to run the place because he was not an astronomer. He was a physicist. And he had been teaching at MIT, teaching a physics course at MIT. And he had some unusual ideas. And one of the things he really wanted to do was introduce photography into astronomy and to really push the observatory in the direction of what we now call astrophysics. Because at the time, it wasn't that. It was really celestial mechanics. It was about where are things in the heavens and how do they move. It was also a time when women's education was debatable. The wisdom of educating women was debatable. So the title of this book, Sex in Education, A Fair Chance for the Girls, makes it sound like it's in favor of women's education. But in fact, this book argued that a young woman who spent too much time developing her intellect would do irreparable damage to her reproductive organs. I couldn't make this up. And one of the first duties of the American Association of University Women was to debunk this theory. And the way they did it was to interview women who'd been to college and ask them if they'd had children. And lo, they had. So this is one of the early photographs. I love this image. You will recognize, many of you, the stars of Orion's belt and the Orion Nebula at the bottom. And of course, the stars of the belt are grossly overexposed, but many stars that no one could see were captured in this long exposure photograph. And that was the real advantage of the photography. The human eye registers visuals just in the moment. But a photograph can accumulate light over time. And so stars that were too faint to be seen, even through the world's most powerful telescopes, would show up on these plates. This is Galileo's image of the Orion Nebula after he looked at it with an early telescope. And he was thrilled to see how many more stars he could see. So it's the same kind of revelation. Most of the glass plates are negatives, so the stars appear black on a white background. Sometimes they photographed transient phenomena. And the most important project at the observatory actually started with a love story. These two people were married to each other. This is Dr. Henry Draper and his wife, Anna Palmer Draper. So he was a medical doctor, also a chemist, but he was a passionate amateur astronomer. And she became his assistant, and they did many interesting observations together. And he was very big on photography. and really wanted to photograph the spectra of the stars to be able to create a classification system. People had the sense that the stars would fall into certain categories, just like animals or plants. And there had to be a way to support that idea. And they had a private observatory and were on the brink of really changing their lives, devoting all her money and his time to this project when he developed pneumonia and died at age 45. So she was bereft, alone, and was looking for a way to carry out his dream because they had no children, and this was crucial for her, and yet she wasn't sure how she was going to be able to do it without him. So here is a spectrum. So you see the light broken down into rainbow colors, and then the black lines that appear where certain elements get absorbed. So the spectrum of a star was starting to give an indication of what chemicals were in the stars, which was very exciting to Henry Draper. He felt that spectrum analysis had made the chemist's arms millions of miles long, because people had thought this could never be discovered. The stars were too far away. And now there was a tool, a way to do that. And then the spectra could also show the motions of the stars. So if the lines got shifted toward the red end of the spectrum, that meant the object was moving away from you. Toward the blue, the opposite, it was approaching. Of course, there was no color photography yet. So his best spectra looked like this. And the idea was to discern patterns in these spectra and use them to create stellar classifications. And Mrs. Draper was an heiress and tried for a couple of years to find people she could hire to run the observatory and carry out this dream. But eventually, it was Edward Pickering at the Harvard Observatory, who had been a friend of theirs, who said that he would be very interested in taking up that project with a little help. And she offered to fund it if it could be named for her husband. So that was easily done. Pickering, by the way, although it was the Harvard Observatory, the observatory had no money from the university. So he had to raise funds. And she was a great source of funding. So when he arrived at the observatory, he found about 6 women already working there, including daughters of the previous director. But with Mrs. Draper's money, he was able to hire more women. Women were a really good deal because they were cheap. He could get 3 or 4 women for the price of 1 man. And so that's what they're doing. They're looking at the glass plates, and they are writing down ideas, observations, and of course these are staged photographs, but you get the idea. So in order to look at a plate, you put it on this wooden stand, and then you look at it with a magnifying glass or a loupe. And of course, I said these are staged photos, so the shades are drawn here, which gives the lie to the picture, because you need the daylight to come in and bounce off the mirror at the bottom here, and then the light shines up through the plate, and you can see what you're doing. And Pickering's idea was, instead of photographing one spectrum at a time, let's get hundreds of them on a plate. And so every little smudge here is the spectrum of a star. And your job is to try to discern patterns in them and come up with a classification system. And this is what he turned over to these women. This is a penny, just for scale. So one of the first people he hired, Williamina Fleming, was actually in the observatory as a maid. And he recognized how intelligent she was and moved her over to the observatory and taught her how to compute orbits and how to look at these plates. And he urged her to try to come up with a system. And she did. She found patterns. She gave each pattern a letter of an alphabet, A, B, C. She'd been a teacher in Scotland, so she was extremely organized. And the problem was her husband, who had brought her to this country, had disappeared on her, and she was pregnant. And so the Pickerings helped her go home to Scotland to have her baby. And she was so grateful, she named her baby Edward Charles Pickering Fleming. And they promised her a real job if she would come back, which she did about 2 years later. And she prepared a publication of 10,000 spectra, which was published as the first installment of the Henry Draper Memorial in the Annals of the Harvard College Observatory. So all the time these plates are accumulating, hundreds, thousands of glass plates, Pickering is nervous about a fire in the observatory, which was a wooden building. So he built this brick building to store the plate library. And they actually moved all the plates. They ran a block and tackle, put the plates in crates, and just slung them down there, 8 tons of glass, and nothing got broken. So Mrs. Fleming had come to this work with really only a high school education. And Pickering promoted her. He made her the curator of astronomical photographs, which made her the first woman to hold any kind of titled position at the observatory or the college or the whole university. Other people who joined later had a college education. Antonia Maury was the niece of Henry Draper, and she had attended Vassar College. She had 8 semesters of astronomy with Maria Mitchell, who was this lady here, the first lady of American astronomy. So Antonia Maury came in, and she developed her own classification system for the stars, which was much more complicated than Mrs. Draper's. So now there were 2. Oops. I am going, my clicker has run away with me. Here she is. So she was given close-up photographs that just had the spectrum of one star on a plate, so she could see a lot more detail, and that's what inspired her to make a more complicated system. And this person managed to combine the 2 systems into something that was so effective that it endures to the present day. We have any astronomy 101 students? You know, when you learn the order of the stars, so Miss Cannon rearranged the alphabet that she inherited from Mrs. Fleming to conform to what was starting to look like a real scientific progression. And so she had to arrange the letters as O, B, A, F, G, K, M. And astronomy students learn the mnemonic for remembering the order, which is O, be a fine girl, kiss me. People always ask me, do I have a favorite among the Harvard women? Yes, and it's Miss Cannon, who had to be one of the most delightful people ever. She befriended everyone. She had tremendous ability. She could look at a spectrum and just know it instantly. No one could figure out how she did that. She had gone to Wellesley College. Here she is as an assistant teacher with her professor, Sarah Whiting, who had taken Pickering's courses at MIT. And Miss Cannon, because she had this wonderful background in practical astronomy, she was the first woman who actually did telescope observations. She was observing variable stars at the observatory. This is from a children's book about her. Well, this is a typical plate that Miss Cannon looked at. Again, every little smudge is the spectrum of a star. And so the photographic emulsion is on one side of the plate. The other side is smooth glass, and you can write on it in colored ink, which is what they did. And so you can assign each one a number, and then as you're looking at the spectra with your loupe, and you decide that's a B star or an F star, and you call that out to your assistant who's taking the notes, and you can get through a lot of stars that way. One of the ways I got to know Miss Cannon so well was through her diaries. There are boxes of her diaries in the Harvard archives, and her correspondence. She wrote to astronomers all over the world, and she also wrote to their children. She befriended everybody's children and got invited to all the weddings. So in order to make a complete view of the sky, you have to have the southern hemisphere as well. So this was the first Mount Harvard in Peru. Pickering sent a team of explorers, adventurers, to the southern hemisphere to find a perfect spot for an observatory. And this was where they set up at first. Over time, they got it together in the lee of this volcano, which was said to be extinct. They took that on faith. Several of these buildings actually house telescopes, although only this one looks like a dome. This was the director's residence on site. Inside this dome was this telescope. So this was a telescope Pickering designed expressly for this purpose. And it took huge format images, 14 by 17 glass plates. And to build this telescope, he needed $50,000. And he found another heiress to give him the money. You know, this is some idea of how charming this person must have been. Her name was Catherine Wolfe Bruce, and this was named the Bruce Telescope in her honor. The people who ran the Southern Observatory, this bearded gentleman in the hat is Solon Bailey. He was in charge, and this is his wife, Ruth Poulter Bailey. They were down there for 5 years, so they took their son, Irving, who was educated in the natural history of the high Andes and went on to become a famous botanist at Harvard. So the two of them worked together, supporting the tradition of having the women in the family in astronomy. And Bailey was expressly interested in these objects, which are called globular clusters. Astronomers are very direct about the way they name things, you know. Big Bang, black hole, globular cluster. You get a picture. And so one of the things he had to do was try to determine how many stars are in a globular cluster. And the only way to do that is to count them. So they would make a see-through screen, little centimeter square boxes, and just start counting from outside in. When you get towards the center, it becomes well nigh impossible, but you can estimate. So they would both count, husband and wife would both count, and then if they didn't agree, they would average the results. But the images all got sent, and this is before the Panama Canal, they all got sent back to Harvard for analysis by the team who would make interesting discoveries from looking at the pictures. And you often hear them called computers, the Harvard computers. And in the beginning, they were computing. Observatories always had computers who computed orbits and did corrections of mathematical corrections needed for recording astronomical observations. But they were actually making discoveries. And Pickering liked to say that, you could see more looking at one of these images than you could see looking through the telescope in the daytime than you could see looking through the telescope in the nighttime. So Henrietta Leavitt may be the most famous of the Harvard women, and she is the person who brought me into this story. Years ago, I was interviewing astronomer Wendy Friedman when she was in charge of one of the Hubble telescope key projects about determining the expansion rate of the universe. And she told me that the whole idea for their project really grew out of a discovery made by this woman in the previous century. And I thought that was really interesting. And I went to learn more about Miss Leavitt and found that she was working in a whole room full of women at Harvard. So she was particularly interested in variable stars, in looking at stars, assessing how bright they were, but then also how their brightness changed over time. And the way she would do that, was with these little gizmos. These were called fly spankers because they looked like fly swatters, but Miss Leavitt liked to joke they were too small to do a fly much damage. And inside each frame is a piece of a glass plate with numerous stars on it, which have already been assessed for their brightness. And there's a number next to each one. And so you can hold one of those over a new plate and compare the stars in the fly spanker with the stars on the plate and make your judgments. And she was especially interested in this object, which can be seen only from the southern hemisphere. This is the Small Magellanic Cloud. And so she was looking at variable stars here and thinking to herself that all of these stars are roughly the same distance from the Earth. So that the stars that really are brighter, that look brighter there, they really are brighter than the others. Usually if you look up in the night sky, there's no way for you to tell whether something is bright because it's really bright or because it's close. But this was the beginning of a way to do that. And there was a certain type of variable star that she studied, and she studied the pattern that they made, brightening and then dimming again. And she noticed that the ones that were brighter took a longer time to cycle through their changes. And she reported that. And it was so significant that that was used to make the first distance judgment to this object. And the guess was tens of thousands of light years. It's actually much farther than that. But she called this the period luminosity relation. So the brightness of the star was related to its period. And this made her world famous. Miss Cannon was also world famous. They were members of the American Astronomical Society, honorary members of foreign astronomical societies. Miss Leavitt unfortunately had cancer and died relatively young, she was considered for a Nobel Prize, but she had already died, and the Nobel Prize is not awarded posthumously. Pickering's encouragement of women drew the interest of one of Maria Mitchell's descendants on Nantucket Island, who wanted to have one of the Harvard women come to the island in the summer and teach the locals astronomy, but also do some important research. And this was the first, this is Margaret Harwood. She was the first Harvard woman to go to Nantucket and do that kind of work, and they loved her. And they hired her immediately and made her the permanent director of the Maria Mitchell Observatory on Nantucket. And she was only 30, just like Pickering was 30 when he took over at Harvard. She was only 30 and became the first woman to be director of an independent observatory. So then the Maria Mitchell family decided to endow another fellowship, which they named for Edward Pickering. So it was the Edward Pickering Fellowship in Astronomy for Women. This is a famous photograph of the Harvard computers. This is Miss Leavitt. This is Miss Cannon. But two of these ladies, Dorothy Block and Mary Vann, they were Pickering Fellows. And that enabled them to learn how to do real astronomy at Harvard, and then go work at another observatory and go on from there. And they had real careers as astronomers. So the Pickering Fellowships exported these women to other observatories. After Pickering died and Harlow Shapley took over, he felt that the observatory really had to start educating more astronomers, that they were producing knowledge, but they weren't bringing up the next generation of astronomers, and that was crucial. And the only money he had to bring in graduate students were these Pickering Fellowships for Women. So he recruited his first graduate students from the women's colleges. This is Adelaide Ames. She went to Vassar. Helen Sawyer, Mount Holyoke. And this is Cecilia Payne, who was from Newnham College at the other Cambridge in England. So they all came on Pickering Fellowships for Women. So Miss Payne really had a background in astronomy, but also atomic physics. And she was really interested in looking at those plates to figure out the abundance of the various chemicals in the stars. And Shapley encouraged her to go for a PhD, which she did. So she was the first person to earn a PhD in astronomy from Harvard University. Not the first woman, the first person. And in her research, much to her surprise, it seemed that the stars were made almost entirely of hydrogen and helium, which went against everyone's preconceived notions. Because once it became clear that familiar elements were in the stars, it seemed that they would be in the same abundance as they were found on Earth. And her findings showed that hydrogen was about 1 million times more prevalent than anything else, which seemed crazy. So Shapley sent her thesis to the reigning expert, Henry Norris Russell at Princeton. And he told her, you better not make too much of this in your dissertation, because this can't be true. But that was her finding. So she wrote it in, and she said, it's entirely possible that this result is in error. And Russell, to his credit, followed up her work, spent about 4 years on it, and finally came to the conclusion that it really was mostly hydrogen, and was willing to publish that and and cite her in his paper. It wasn't all work at the observatory. They had a lot of fun. This was a New Year's Eve performance of the observatory pinafore, with Miss Payne in the leading role. Have you ever noticed how often astronomers are musical? No, it's uncanny how often that turns out to be true. Galileo, they were all musicians. And so she played the violin and sang, and there was an observatory orchestra also. So in this performance, everybody got, of course it was based on Gilbert and Sullivan's Pinafore, and there was the sisters and cousins and aunts were the computers, and Pickering was the character also, and his gentlemanly manner was spoofed. And when he gets angry, he says, "Oh, Polaris." So one of the last things Miss Cannon did was to endow a prize for women astronomers. She'd been given a prize that included a cash award of $1,000, and she invested it to create a prize to encourage women to go into astronomy. It's called the Annie Jump Cannon Prize. And at the beginning, there wasn't a lot of money, so she thought it'd be nice to create a necklace or a pin that the winner could keep after the money had been spent. And this is the Annie Jump Cannon Prize that was awarded to Margaret Harwood. It is still at Harvard in the Schlesinger Library, the history of women in America. And this is Marta Bryan. She is this year's Annie Jump Cannon Prize winner. This prize was scorned by some women for a number of years. You know, they felt, well, if it's a women's prize, maybe it's not as good. I'd rather win a prize that's open to everyone. But they've upgraded the prize. There's more money now, and the winner gets to give an important talk at the annual meeting of the American Astronomical Society. So it's a big deal. So the hundreds of thousands of plates are still at Harvard. And this is how they're stored in these, they're in a paper envelope, and they're very well, or it's like a library. The curator knows exactly where everything is. If you want to look at the sky on a certain date, it's a matter of moments to pull the plates that you need. And then there are also these are the logbooks that the assistants were writing their notations and thoughts in. And there's an ongoing effort to digitize all of this stuff. Those of you who have spare time and are good at deciphering scrawled handwriting, there's an online platform where you can look at the logbooks and type in what you think they say. This is one of the last images. This was taken, the southern station had to be moved from Peru to South Africa, which is where this image was taken. And of course, this is obsolete technology now, but the pictures certainly are beautiful. Here are my Lego characters. Miss Leavitt, her period luminosity relation is now referred to by people in the know as the Leavitt law, making it parallel with the Hubble law. And why not? Here's Miss Cannon with her stellar classification, and Miss Payne with the true abundance of hydrogen and helium in the stellar atmospheres. And as I said earlier, I was not, well, I said earlier I couldn't show you a glass plate, and this is why. So these are works by artist Leah Halloran. This is a painting using drafting ink on a kind of tracing paper. And then this is used as a negative. It's put over a piece of photographic paper with the chemicals on it and set out in the sun for a few hours. And so the starlight creates the darker version, the cyanotype. And hundreds of feet of wall space at LAX are currently devoted to Leah's images. Here is her take on the Small Magellanic Cloud. These are gigantic pieces, about 6 feet square. And because it is part of the Art in the Airport project, I got to write the wall text. That was a first. And my plate is on loan. It's in a little display cabinet with these images, so people who are interested can see what the plates actually look like. And of course, this is another posed shot, but I really do love this picture. So this is Margaret Harwood down on the floor. This is Cecilia Payne, Antonia Mori, and this is Miss Cannon. She's too busy to look up for the picture. And I came to the story because it was just so interesting that the woman from 100 years ago was intimately connected with the Hubble Telescope Key Project. But in the course of writing a story about women in science, I had to confront my own unsuspected misogyny, because I kept getting surprised by everything the women did. It just, every time. And I really started to get annoyed at myself. Why did I have such a low expectation about these women? Because nobody ever said to me, you can't do that because you're a girl. And so where had this come from? But I conclude that I just absorbed it as a product of growing up in the 1950s. And I wasn't alone. Even younger people. Before this book was published, I asked about 12 experts in the various disciplines to read it for technical accuracy, because you don't want to find that out later. So Alyssa Goodman, who was the professor of astronomy at Harvard, was one of my people. And she apologized to me. She said, you know, I have to say I'm not really paying attention to the astrophysics because I am gobsmacked by these women. Here I am at Harvard, I've heard all their names, but I always thought it was something cute or quaint. I never realized they were actually doing science. I thought, wow, there it is again. So now I've got the religion. And now I'm really interested in stories specifically about women in science. And I'm working on something now, because this question often comes up, what are you doing now? About Madame Curie, the icon of woman in science. Because I've learned something about her that I think is not well known, which is that she hired, mentored, took under her wing about 45 women who wanted to become chemists or physicists, and passed through her lab. And I think it's a really interesting story. But I will close here and welcome questions if you have them.
Thank you very much. Time for questions, comments. Claude?
I was really fascinated to hear of Shapley's role in mentoring all of these women. At the same time, he was somebody who has a reputation for being extremely arrogant and fought a lot with Hubble because he didn't want to believe that the Milky Way was as small as it actually is. Leavitt, for example, did she find herself caught in the crossfire in all of that?
You all hear the question? No, she didn't. And if you spoke to Shapley, he would tell you Hubble was more obnoxious than he was. They really didn't like each other. Miss Leavitt never got caught in any crossfire. Hubble certainly used her discovery because he saw one of her variable stars in the Andromeda galaxy, and that's what convinced him that it was beyond the Milky Way. That was the key discovery.
Can you describe was it a spectrometer or what was the piece of equipment like that these people were, because it was black and white, and can you describe it for us?
Yeah, how did they get the spectra? So they put a prism, it doesn't look like a triangular prism that you see at a science equipment display. It looked like a sheet of glass that had a wedge shape to it, and it fit over the light gathering end of the telescope. So it split all the light into the spectra. And so when the camera at the eyepiece end was receiving these images and recorded them on the photographic plate.
So the years of some of the heroines of the story go up into the 1950s and even further. But something happened in the 1950s,
Something happened.
Which you referred to, and I was there too. But how would you describe it on the ground there in Harvard, where women had been such a presence, a continuing presence right through the 20s and beyond?
Yeah.
So can you describe something of what that process was?
Well, I'll try. I'm not sure that I have a complete understanding of it. After World War II, there were actual machine computers. So computer went from being a job description to being a thing. And there was more reliance on computers. And there was more movement to employ returning veterans. And there were other social trends that created the feminine mystique. And it just all fell apart. You would think there would have been a trajectory, but there really wasn't. And now about a third of the employees at the Center for Astrophysics are women. But there's a new director, Lisa Keeley, and she's the first woman who's ever been the director. And there's a new curator of the glass plates, and it's the first man to be the curator of the glass plates. But the plate collection has been named for Mrs. Fleming, which is very nice. Although I wish they would name something for Pickering, because he really deserves that.
Yeah. I was wondering how unique it was at this time for an institution to be, well, predominantly women, that they were doing the science and making the discoveries, as you were saying, rather than having jobs that were more menial.
It was very unusual. As I said, the existence of the director's residence right next door to the observatory really had a big effect. And then Pickering's attitude. Pickering was married to Lizzie Sparks, so she was the daughter of Jared, a historian named Jared Sparks, who had been the president of Harvard. So she was extremely well educated. His mother was educated. He was open to having smart women around. That was not true everywhere. Most observatories had men as computers, and they didn't have women in those roles. And Miss Cannon, who traveled a lot, would always make a note in her diary about there are no women at this observatory. She noted that in England and Germany. So it was unusual. And Harvard especially, you know, it was an all-male school at the time. Even now, I'm not sure they're particularly welcoming to women. But the observatory was a wholly separate entity. And Pickering really had freedom to do what he felt like.
I know there's like a domino effect that happens with every scientific discovery. So how did Leavitt's discovery of a star cycle affect astronomy as a whole?
How did Miss Leavitt's discovery affect astronomy as a whole? Well, now there was a way to measure distance. So Shapley got famous for really studying the Milky Way and figuring out that it was so gigantic that it probably was the whole universe. And so he was arguing with people who thought that those little spiral things they could see were really other Milky Ways, more distant. And he thought, no, they were embedded in the Milky Way. But it was with those stars, it was Hubble's ability to see one of Miss Leavitt's stars in the Andromeda Nebula that put the distance way beyond the borders of the Milky Way. So that had a huge effect. And then the Milky Way is just one galaxy among many. And even now, to determine the expansion rate of the universe, they're using other objects, but it's all that same principle. You know how something looks close up, and you see it far away, and you judge the difference in brightness, and then that gives you a distance.
Any more questions or comments? Probably not, then let's thank Dava again for a fantastic lecture.
Thank you.